Let's go for our last example where the left hand side of the equation is the same and the right hand side has changed. This means the number 6 times 2 to the t. Only 2 is raised to the t. That's what I have put parentheses. So we have 6 times 2 to the t has to be equal as, or has to be written as a polynomial times number to the t. Okay, polynomial again is 6, which is a polynomial of degree 0. And s to the t, here you have something, is 2 to the t. Therefore, s is equals to 2. And now k is the number of times s equals to 2 is a solution of the characteristic equation. Now, the characteristic equation from before has solutions 5 and 2. So the 2 was solution once. S equals to 2 appears once in the characteristic equation, hence k is equals to 1. Let's see how this builds the particular solution. We need a polynomial of the same degree, 0, meaning a constant, 2 to the t, and now t raised to k, t to the first power, t. So this means the particular solution here is a constant 2 to the t times t. To find the constant, as before, we have to use our equation. But first of all, we write the particular, which we know is a 2 to the t times t. Now the particular in t minus 1 will be a 2 to the t minus 1 parenthesis 2 minus t minus 1. And for t minus 2 will be similar. This is 2 to the t minus 2, t minus 2 and t minus 2. Just 1 second, let me write this thing clearer because it doesn't look like t minus 1. So let's put here t minus 1. Now, back to the equation. Equation here, you can see in this, the equation is yt minus particular minus 7 times yt minus 1 particular plus 10 times yt minus 2 particular equals 6 times 2 to the t. Replacing for these three terms here, we have a 2 to the t times t minus 7 times a 2 to the t minus 1 times t minus 1 plus 10 times a 2 to the t minus 2 times t minus 2 is 6 times 2 to the t. Let me write here, this is not clear, this means t minus 2, as you can see here. Okay, so how do you solve this? There are many ways. The easy way is to give a value to t. And the value we're going to give is not to have any negative exponent, so we'll give the value 2, because when t is equals to 2, you have that t minus 2 equals to 0, and that's the easiest way. So let's see. We make t equals to 2, we have 8 times 2 squared times t, which is 2, minus 7 times a 2 to the first power, and 2 minus 1, which is 1, plus 10 times a 2 to the 0 power, times 2 minus 2, which is 0, must be 6 times 2 squared. Okay, so these are 8a, and here 2 times 7 is 14a, and this is 0, and this is 4, and 6 times 4 is equals to 24, so has to be 24, minus 6a equals 24, a equals 2 minus 4. And hence we have our particular solution is equals to a minus 4 times 2 to the t times t. Let's write it like minus 4t times 2 to the t. And the general solution for this is the homogeneous plus, this is a y, plus the particular, which was constant 5 to the t, plus constant 2 to the t, minus 4t parenthesis 2 to the t. How to find C1 and C2 requires using initial conditions, which will be the next part.